The graph below contains the rectangle ABCP. Draw the image of ABCP under a dilation whose center is at P and a scale factor is 1 2/3. What are the lengths of the side AB and its image? So we're going to do a dilation centered at P. So if we're centering a dilation at P, that means that every other point is going, and its scale factor is 1 2/3. That means once we perform the dilation, every point is going to be 1 2/3 times as far away from P. Well, P is 0 away from P, so P is still going to be, its image is still going to be at P. So let's put that point right over there. Now, point C is going to be 1 2/3 times as far as it is right now. So let's see, right now it is 6 away. It's at -3, and P is, or its x coordinate is the same, but in the y direction, P is at 3, C is at -3, so it's 6 less. We want to be 1 2/3 times as far away. So what's 1 2/3 of 6? Well, 2/3 of 6 is 4, so it's going to be 6 plus 4 is going to be, you're going to be 10 away. So 3 minus 10, that gets us to -7. So that gets us right over there. Now point A, right now, it is 3 more in the horizontal direction than point P's x coordinate. So we want to go 1 2/3 as far. So what is 1 2/3 times 3? Well, that's going to be 3 plus 2/3 of 3, which is another 2. So that's going to be 5. So we're going to get right over there, and then we can complete the rectangle. And notice, point B is now 1 2/3 times as far in the horizontal direction. It was 3 away in the horizontal direction. Now it is 5 away from P's x coordinate. And in the vertical direction, in the y direction, it was 6 below P's y coordinate. Now it is 1 2/3 times as far. It is 10 below. It is 10 below P's y coordinate. So let's answer these questions. The length of segment AB, well, we already saw that. That is, we're going from 3 to -3. That is 6 units long. That is 6 units long. And its image, well, it's 1 2/3 as long. We see it over here. We're going from 3 to -7. 3 minus -7 is 10. It is 10 units long. We got it right.